Hello everyone, I'll move on in this video to the final part of the chapter of trigonometry, solving trigonometric equations. Probably the most important and then also the most challenging for many of us. So before I touch further, before you really get into this topic, prerequisites. So prerequisites, some of the topics or knowledge that you will need is that the identities or the proving identities, that one will be really important, and then the basic concepts of trig ratios, of course that's definitely, and then trig functions of any size of angles, that will also be really important. Remember the quadrant properties, quadrant 1, quadrant 2, quadrant 3, quadrant 4, where this is all positive. The range is 0 degrees until 90 degrees, or in radian also, okay? This is a range of 90 until 180, where the sign is positive. Where they put a CAST, cast. This is T, tangent positive. This is cos positive. It means that aside from this positive, then the rest will be negative. So these are really important before you go through the trigonometric equations. And then another tips, some of them is like, for example, the point number 1, the cast properties are ruled, which is the quadrant properties earlier. So you need to really know where is it negative, what the values are, where is it the value, where is the quadrant 2, which one is quadrant 3, and so on. Trigonometric identities. Sometimes it's needed, sometimes it's not. Sometimes it's really basic. I'll give you the basic ones. I'll give you the complex ones as well. The number 3, algebraic formula or properties. Similar to whenever you're dealing with trigonometric identities, it's really important for us to use what we have learned all this time, right? Including especially factorization. So anything related to quadratic, it will probably appear again here. Number 4, if the question is given in degree measure, put it in degree measure. So you have to read carefully the question. So if the one given in radian, put it in radian. So example. So this is one of the basic questions. Find the values of theta in the interval. See, the given domain is radian, so your answer will be in radian measure as well, for which this value of sine theta will be half. So this is an example of solving it by using graph. I'll show you by using algebra as well. So if you're using graph, of course the graph will be given, right? And then see what does it mean by sine theta equals half. Of course, if you go back to simultaneous equations, it means that you need y equals sine theta, you need two graphs, right? And then y equals half, where this is the case, and then this is the curve. And you see there is 1, 2, 3, 4 intersection for this domain. And then how do we get the values? That's we need calculator, or we need software, or we need the algebra. So at least you can get the idea of, we get 4 intersections, it means we get full solutions or full roots. Now in terms of how we do it using algebra, so let's put it this way, sine theta equals half. The most common domain given is actually between 0 until 2 pi, or until 360 degrees. That's the most common. I'll start with this first. So the way we do it this way is that it's really important for you to notice that sine theta equals half, which means it's positive, right? It's a positive value, which means in the case of sine theta, that means theta either in quadrant 1 or theta in quadrant 2. That's at least the range of values. And then what you need to have, next one is that you use your calculator or use your brain at least. So sine theta equals half means that theta is sine inverse half, which is 30 degrees, or in terms of radian, that will be pi on 6, right? And then you know, pi on 6 is already in quadrant 1. So here, theta is pi on 6, that's good. But then here, for the quadrant 2, so this is where you recall back the quadrant properties. In quadrant 2, the property that I haven't put it here, which is really important, is this is 180 minus theta, or it means pi minus theta. This is 180 plus, or pi plus. This is 360 minus, or 2 pi minus. So you go back to the dictionary that I mentioned, right? So over here, it means that you will have 2 pi minus pi 1 6. So that will give you, what is that, 12, 11, 6 pi. That's it. So you got two answers. But then the domain actually is not 0. So we should go until negative 2 pi as well. So how can we get the rest of them? So the simple idea is that because you need the property, right? Here, in terms of the period, it's 2 pi. Meaning that if you go until negative 2 pi, you add another 1 rotation, if that makes sense, right? So if you see the graph as well, this is the main part of the graph, but here is another rotation, so there's another frequency. So what you can do instead that to expedite the process is that if you do the algebra all over again, what you can do is that you subtract by 2 pi, or that means subtract by 1 rotation, or sometimes plus 1 rotation depending on the domain. So here it means you will have negative 11 6 pi. This is also the same, 11 6 pi minus 2 pi. So you get negative pi on 6, if that is okay with you. So you see how we deal with this. Let's see. Yeah. Sorry, my bad. It shouldn't be like this. So this one should be pi minus because it's quadrant 2. Sorry for the mistake. So this should be 5 6 pi. This one will be 5 6 pi as well. Sorry. So 12 minus, so that will be negative 7 6 pi. So I think that's it. So you can try using GeoGebra as well to check whether the answer is correct or not. But in terms of how you do it, this is how you put it into the algebraic terms. So again, you check the sine theta equals half. You do it because it's positive, quadrant 1 and 2. So then you find the value, and then over here you're using the properties in the quadrant, the cast rule, and then you do the rotation if you need. Sometimes you don't need it, sometimes you need it. Then here it goes. So these are the values that we get. Then we get all the 4 solutions. In the next video, I'll give you more examples on dealing with more complicated types of equations, for example, like this, or maybe this, even worse, maybe using the reciprocal functions as well. Okay, so please take a look over this idea again. I'll see you in another video. Thank you.